All right, so you've already got quite a lot of math vocabulary going on. What we're going to do today is talk about some more fundamental just skills that you need. We're going to talk about how to apply these in class to kind of some complicated problems. So this is really just the basic skill that you need to be able to do. This is a skill in geometry. It's equivalent to like adding or subtracting in algebra, right? It's just super basic and you need to know how to do it. So we're going to be talking about distance and midpoint. And the first thing I want you to write down is what we call segment addition postulate. Remember, postulate is something that's just kind of common sense, so there's not really a ton of like rule or proving that goes with it. So this is called the segment addition postulate. So remember, segments have endpoints. Notice that this is the segment AB and BC. And all segment addition postulate says is that if you add AB to BC, you will get the entire thing. All right, so you're going to write that down. You're going to draw this picture. You're going to call it segment addition postulate, and then you're going to write down this little formula right here. If you notice, it does say that those points are collinear, just meaning that they're on the same line. Okay, if you want me to do like just a little example real quick of how you might see segment addition postulate, you might have a picture that looks something like this, and it might say, let's see, I'm just going to call these A, B, and C. It might tell you that AB is 2 inches long and that the entire distance from A to C is 12 inches long, and it might ask you how long BC is. So hopefully there's some common sense going on there. If this little piece is 2 and the whole thing is 12, 2 plus how many more is going to give you 12? If you aren't sure, you can write a formula, but this is really just going to be 10 right here, right? 2 plus 10 would give you the entire thing, 12. All right, so here is finding distance. Now, when you read up here, it says finding distance using the coordinate plane or on the coordinate plane. It says the Pythagorean theorem states a squared plus b squared equals c squared. Now, one thing you may not know about me so far is that I do not like to memorize things. So as many times as I can reuse formulas, I will. So there is this thing called the distance formula. It's in this box, and it's this big square root. And I'll tell you that I never use that formula. I'm not telling you that you can't copy it down and you can't use it, but distance is really the same thing as Pythagorean theorem. So you probably need to write that down. The distance formula is the same thing as Pythagorean theorem. So when I say distance formula, I'm going to use a squared plus b squared equals c squared. And I'm going to remind you that that means, so I would draw this triangle out so you remember A, B, and C. So C is the hypotenuse, and that's the one that's going to be the distance that you're looking for. So let's look at an example of how you can use the Pythagorean theorem to find the distance between 2 points. All right, so we've got a picture here, and we're going to find the distance of these segments, AB and GH. All right, so AB. Notice that it's drawn on this picture. What you could do is you could draw a little Pythagorean theorem triangle, like a right triangle, and count. I'm also going to show you how you can use that just looking at the coordinates in case it's too big. So notice that this vertical part right here is too tall. That comes because how far apart are 4 and 2? And hopefully on a number line you realize that 4 and 2 are 2 spaces apart. All right, and then this other length is, if you count 1, 2, 3, 4, 5, that's because -4 and 1 are 5 spaces apart on a number line. So that's going to give me 5 squared plus 2 squared equals c squared. Now at that point, you can use your calculator if you need to. 25 plus 4, that's going to give me 29. Remember, the last part of Pythagorean theorem is to take the square root. And the distance here, we can keep these, we call this exact where we don't round it. This is the square root of 29. We can leave it just like that. All right, so GH, this time I'm going to do this not looking at the picture. So you can pause and look at the picture and see how long the sides of the triangle are if you want, but I'm just going to look at my numbers. So first I'm going to ask myself, how far apart are 2 and -2 on a number line? Hopefully you realize those are 4 apart. How far apart are 0 and -4? So notice I'm joining up the x's. I'm counting from x to x and from y to y. So from 0 to -4 on the number line is also 4 apart. So that's 4 squared plus 4 squared equals c squared. So I'm going to do the same thing I did on the last one. All these numbers you can get in your calculator. and take the square root. So on this one, the distance is 32. So if I was to ask you which segment is longer, hopefully you would say that GH is longer than AB, right? Because the square root of 32 is bigger than the square root of 29. All right? All right, so here's the last concept we have to talk about today, and this is midpoint. So the first thing that we need to do is write down some of these definitions. So we're going to write down the midpoint of a line segment is really the point. It says it's the point that divides the segment into two equal segments. It's literally just the point in the middle. That's why they call it midpoint. So in this example, M is the midpoint of the segment PQ. So if we look at PQ as the entire segment, M is in the middle. And the way we know it's in the middle, it doesn't just mean anywhere in the middle, it means perfectly in the middle. So it divides PQ into two equal sections. Okay, and another word for that is to bisect. So M is the midpoint, but the midpoint itself bisects or cuts in half that segment. Now the last little thing I want to show you is just some notation that you see here. So this line L is the one that's bisecting. Notice these little tick marks right here. So I'm going to mark them in green. Those little tick marks are a way that we can mark on a picture that things are congruent without having to put numbers on them. Because sometimes we don't need the numbers, we just need to know that things are equal size. So what we can say, these tick marks, you can make a note, these are the ones that, these are marks for congruency. And what they tell us then, the statement that you want to write down with this picture, so make sure you have this picture drawn, is that MP, the segment, so make sure you put the little symbol, is congruent to MQ, the segment. All right, that's exactly what those tick marks mean, that those two pieces are congruent. They're equal to one another. So let's look about how to find the midpoint, particularly when we're looking on a coordinate plane. Okay, so again, I don't particularly like to have formulas because they're not easy for me to remember. I'm not very good at memorizing things. If you are, you're welcome to write down this formula, but I'm going to show you the shortcut of how I do these problems. So when I say midpoint formula, I think about the middle. When I think about the middle as a teacher, I think about grades, and we find your grade by doing your average. Now remember, when you find average, you add all the things together and divide by the number of things that you're adding. For instance, if I was to find y'all's like average age, I would add everybody's age in this class together and divide by 15 or however many of you are in this class. Okay, that's how we do average, right? So midpoint is saying the same thing. We've got these two endpoints I'm showing you on this example. You've got these two endpoints, A and B. And it's telling you to add, notice in this first little section, it's telling you to add the x's together and divide by 2 because you have two x's, one from the A and one from the B. And then it's telling you to add the y's together and divide by 2, and that gives you the y coordinate. Now, the midpoint is not a number, it is a point. So because midpoint is a point, the answer is an ordered pair. It's an actual location on the graph. All right, so let's take a second to look at an example of midpoint. They've given me P and Q down here, and they want me to find the midpoint M. So I see that the x values here are 4, -4, and 2. I'm not doing distance, so I don't care how far apart they are. I'm finding the average between them. So I'm going to say -4 plus 2, and because that's two numbers, I'm going to divide them by 2. All right, and I'm going to go ahead and map out. This is for the x coordinate. I'm going to work this out for a second. So -4 plus 2 is -2, and then divide that by 2 is going to give me -1. So the x coordinate of my midpoint is at -1. All right, now let's look at the y coordinate. If I do the y coordinate here, I've got 1 and -3. So for my y coordinate, I'm going to find the average because I'm looking for the middle. 1 plus -3 divided by 2 because there's 2 points. That's -2 divided by 2. That also gives me -1. That's just a coincidence. You're not ever really going to find them the same. Sometimes you will, but sometimes you won't. All right, so remember, this is the midpoint. So if you were to plot P, Q, and M, it should be that M is in the middle. And just so you have some proof, that's me. I went ahead and plotted P, Q, and M, and notice that M is perfectly in the middle between those two segments, or those two endpoints rather, and that's what we want.